Today we're going to look at absolute value with inequalities. So if you remember from the end of chapter 2, when we were working with equations back in chapter 2, when we solved absolute value equations, oftentimes we had to translate it into two equations to solve because there were multiple values of x. With inequalities, when we solve them, we get usually a value that we call a boundary. And just like with equations with absolute value, inequalities with absolute value will often have two boundaries for our variables. And we have just worked with inequalities with multiple boundaries that are compound inequalities. So you notice something here. We have a couple of if statements. If the absolute value of x, or an expression, is less than a number, then we can translate it into an and compound inequality. And I'm real fast going to step in here in some of my blank white space and show you something like this. So the absolute value of x, we're going to make this really simple, is less than 5. This is asking us what numbers are less than 5 steps from 0 on the number line. Well, there are two numbers that are exactly 5 steps from 0. They are -5 and 5. So what numbers are less than -5 steps from 0? Everything in between -5 and 5 is less than 5 steps from 0. So how do we show in between? That's our compound and. So that's why that statement is true. The converse is the compound or. So the absolute value of x, let's say, is greater than 5. This would say for what values of x, or what numbers, are more than 5 steps from 0 on the number line. And there are two distinct possibilities. The common one you would think of is that, okay, numbers bigger than 5. Anything bigger than 5 is more than 5 steps from 0 on the number line. But we have to remember the other direction as well. Because if you go to your negative numbers, like -6 is more than 5 steps, and -10 is more than 5 steps, and -100 is more than 5 steps from 0. So anything smaller than -5 will be more than 5 steps from 0. So greater than absolute value inequalities become compound or statements. So that's me explaining what we see above. Now I'm going to get rid of that because it's going to be in the way. And let's actually get through these examples. First example, the absolute value, already by itself, remember from when we dealt with equations. First step, if absolute value is involved, is make sure the absolute value is alone. There's nothing on the left side of this with the absolute value. It's less than +12. First of all, is that possible? Yes. We can definitely be smaller than 12 with absolute value. So if it's a less than inequality, we are to translate this into a compound and by saying -12, so we take the opposite sign, is less than our absolute value expression, is less than our regular 12. And we solve this as we would any other compound inequality. We subtract 3 from all 3 portions, and we get -9. I'm sorry, that's not -9, that's -15. Is less than x is less than 9. As far as the graph goes, I'm going to squeeze it in beside here. Actually, that's way too small. So we have -15 and 9 that we're interested in, and you know I expect 0 on every number line. At -15 and 9, we have open circles because this is a strict inequality, and we are in between those two things. So there's every value for x that would keep us under 12 steps from 0 when plugged into that expression. Next example, we have to start by getting the absolute value by itself. So we're going to add 7 to both sides, and that gets us the absolute value of x is less than 4. And can absolute value be smaller than a positive number? Sure. This is fine. So we can go straight to our translation. It's a less than style inequality. So that means we start with our negative value, so -4. is less than x is less than 4. This one's kind of nice. It's just the x and the inequality, so we don't have to solve this compound inequality. We're just writing it and graphing it. So we put -4, 4, and 0 on our number line. We put open circles. We connect. In our third example, the absolute value is not yet alone, so step 1 is to get it to be alone. We divide both sides by 2 to get the absolute value of x is less than or equal to 3. Now, absolute value is less than or equal to, but less than is the important part. So this is a compound and -3 less than or equal to x less than or equal to 3. You'll notice here, because it's a less than or equal to, we keep both of the inequalities in our compound, less than or equal to. And graph. Again, this is a nice one that doesn't make us solve anything after we have translated. These are or equal to, so we will fill these circles in. I know decimals scare you, maybe a little bit. They shouldn't. Go ahead and add your 4.5 to both sides. Luckily, the 0.5s combine to make a whole 1. 7 plus 4 is 11, plus the extra 1 is 12. And hey, we've seen this before. It's number 1, basically. The only difference now is that it's less than or equal to instead of less than. So now we'll get -15 is less than or equal to x is less than or equal to 9. Same graph as number 1, or the first example, just with filled in circles. And now some greater than examples. First step, as always, is to make sure that our absolute value is alone. Can absolute value be greater than a positive number? Sure. We're in business. Greater than gets translated into a compound inequality. The common sense part of it is actually what I'm going to write as the second inequality, which is x has to be greater than 9. Or, what else would fit the description of an absolute value of x being more than 9 steps from 0? If x is less than -9. So greater than statements get split into a less than and a greater than. I should say a less than or a greater than. Less than inequality statements with absolute value become double less thans because you're in between two things. Again, this was strict, no or equal to, so both of our inequalities are no or equal to. Slap down our -9, our 0, and our 9, empty circles. This is an or, so we're arrows out. Next example, start by adding 20 to both sides. Always get your absolute value completely alone before you do anything else. -13 plus 20 is 7. If the absolute value of x is greater than 7, that means that there are two possibilities. Either x is greater than 7, or it is smaller than -7. Again, these are strict, so empty circles and arrows out. I'm going to fix that so the circle is where it belongs. Okay. Get your absolute value alone if it isn't. Now this time, we have the absolute value of an expression. So we actually do need to write this guy out. Actually, I'm gonna put that right back in a minute. But remember, the first obvious statement is, okay, well, this will be true if x minus 8 is actually greater than or equal to 6. But it can also be true if x minus 8 is less than or equal to -6. We just want x minus 8, the expression, to be more than 6 steps from 0. You can accomplish that by being either more than or equal to 6, or by being less than or equal to -6. Solve each one of these independently. So add 8 to both sides. That's going to get us x is less than or equal to 2, If I add 8 to both sides on this guy, we're going to get x is greater than or equal to 14. 0 on every number line. So 0 to 14, less than or equal to, so closed and left, greater than or equal to, closed and right. And finally, we're going to subtract a half. We're not going to freak out about the fraction. It's not that bad. 4 minus 1/2 is 3 and 1/2. Now, again, we have expression greater than or equal to value. So we're going to have to separate into the expression. So x plus 2.5 is greater than or equal to 3.5. We also have the negative possibility, which is that the x plus 2.5 is less than or equal to negative 3 and 1/2. We will subtract 2.5 from each side of these inequalities. That'll get us x is less than or equal to, oh, let's see, that's going to be negative 6. Or that'll get us x is greater than or equal to positive 6. I'm sorry, not positive 6. That didn't feel right to me. I know why they didn't feel right, because I added them. I'm subtracting. 3.5 minus 2.5 is not 6. You can't subtract from 3.5 and get bigger. That makes sense. How about 3.5 minus 2.5 is 1? So we have negative 6, we have 0, we have 1. Fill it in circles at both because we are or equal to. Less than or equal to at the negative 6 is arrow left. Greater than or equal to at the 1 is arrow right.